How good is AI at competitive programming? Welcome to Frankly Developing. I'm your host Frank. Personally, I've participated in world championship competitions for programming. That's why I'm interested in how AI can do. We'll see how it works, how it fails to do some things, but we'll also take a look at how we deal with this information as professional software developers. What do we take out of this, and how do we learn to clean up this AI code and the mess it got itself into? So this is the game I picked. It's called One Deaf Woman, and it's based on, basically inspired by Santorini, the board game, which in turn is inspired by Santorini, the real city, awesome one. But let's get back to the game. It's hosted on Coding Game, which is a nice little platform. I'm not affiliated with them in any way, but I like the platform to be able to experiment, try things out, and have this competitive environment where you can do multiplayer bot programming competitions. So what does the game really look like? You see you have these individual agents that can, on each turn, you can move one and then build up a tower to the next height. As you could just see, you can push away the other one as well, and then move them through that push in some unfortunate position, though you cannot move them off the game board. That's not a legal move. You can also build up these towers to one level here in the center, then on a second level, eventually on a third level, which shows these yellow stars on which you can move and then score actual points to win the game. Every single turn you have to increase one field's height, and once you reach level 4 you can no longer pass these fields. That will eventually lead to the conclusion of the game, since you will not have any more fields left to move on. So let's get started with the AI. I'm using ChatGPT 4 for this, and I can pass the entire rule description for the initial game setup to the AI and ask it for some code. And it actually gives me these outputs that show some main points that need to be done and the strategy before giving me the actual code, which is kind of good. But if we look closer to these things, we notice a few oddities. The 4 points on what needs to be done, point 1 is clearly parsing the input. Okay, that needs to be done, I agree. Points 2 and 3 are kind of redundant. So you want to implement a strategy to choose which action, and then you want to decide which action. It's the same thing, really. And then point 4 is just plain wrong, because you don't need to ensure the validity of your action. If you read the entire rule set, there's actually a section there that says the input you get are already the legal actions, so you can just parse them and pick from them. You don't have to check their validity at all. Let's take a look at the generated code. The initial code that was generated wasn't actually doing anything, so was just outputting more or less the same command over and over. And so I immediately asked it to give me another one that does a little bit more. But what we can see here is that already this is reading all the input. Step 1, it's parse all the input, which it's doing really, really well. And that's actually quite a time saver. I mean, in Coding Game, you get the input reading already as a starting point. If you select your language, that's already there. So it's not a specific help in that case, but in general, this would be a lot of code that is just quite a lot of code to write and annoying. There are some things that in professional programming we wouldn't want to do, right? Ignoring the nulls that can come here. Obviously, it's not validating any of the input and just assumes this to be true, which for competitive programming is just the standard. That's why you get the specification. You can rely on it, so you do rely on it. Don't waste your time on anything like that, and just read all of that stuff. We have the size of the board, the units that we have per player. There's the grid. It's reading in the grid line by line, and then basically assigns them to this grid variable. It parses the units from us and from the enemy. Just doing fine here for both of these loop. Units per player. Positionings has 2 values on each of these units. And there's these legal actions we already talked about, which it parses as well. Not exactly parsing, it's just reading the entire string for the legal action and then just adding that to the list of actions. And here's the main logic actually, which says choose an action and do it by writing it to the console. This choose an action, however, when we look more closely, let's break this a little bit apart so you can read it better. Move it over there. So it uses a random number generator. It looks at scoring actions, which apparently are only the move and build actions. And then the action has to lead to a scoring. And if it finds one of these scoring actions, then, or more, it picks a random one of those, which is a good starting point. Otherwise, it just picks any random action. Now, it tries to decide here if an action leads to scoring, while saying, oh, you have to implement here the logic to check if an action leads to scoring. There's a placeholder, implement it based on the game rules and action details. Oh, thank you for the placeholder. Replace with actual logic. Oh, that was what I wanted to do, but okay. So far, it just says it scores if you have a 2 height. So if the action contains a 2 is actually not the precise way to measure that. What it does measure is basically, or what it does decide here is the direction. And there is no real possibility for an action to contain a 2 at all. Like, this is just wrong. It's not even a placeholder, it's just plain wrong. Next, I asked the AI to actually implement this placeholder logic. And that is when all things broke down, really. So when I looked at the resulting code, the first thing is it just messed up the input parsing. Like what used to be correct and shouldn't be touched by that command was actually modified, and it just forgot to read the opponent's units. So since you didn't read a part of the input, the rest of the input really doesn't match up and it just crashes. And then it also did another change that was unintended, and it was changing the action selection. If you look at this resulting code now, it's always picking like the first action that scores, or otherwise the first action. Like the whole randomness is now gone, which is okay in general, but not what I want really, so you have to be really careful that it's not doing any unintended changes there. Finally, let's take a look at the actual decision logic. As you can see, it's splitting this action string, which is okay. It depicts the unit index, the move direction, the build direction. The index is not starting at 0, but that's actually correct, because the first one is this string move and build, for example, and then the index, and then the 2 directions. So that's okay. Now, it takes basically the unit and its position, which is 2 ints, x and y. Again, like typical competitive programming, you know that the number of units and the index are valid and work together, so you don't really check anything, you just hard index this array. And then this is how it basically combines these things. The move direction plus the unit position gives you the new position. And eventually the same thing for the build position. Pick the new position, put the build direction on top, and you have the build position. What's interesting to note is that while none of these other things here are really checked, it does spend some effort here to check the validity of the move result. But by the definition of the problem, again, we are guaranteed valid actions as input, so there's no point in doing this at all. Similarly here for the check for the building position if it's valid, and it basically just says this is not a legal action or a scoring action in particular if that is the case. The actual decision now on how to score is this one. It's looking at the position you built, which is next to where you moved, and sees if it comes up to height 2. Which is again still totally wrong, because you score when you move onto a height 3 position. So this does not score at all. And I did a little bit of work to get it actually running, And you can see that there's no chance that you can win with this at all, like not even against the most easiest AI opponent there. That's supposed to be the tutorial. So it doesn't even beat that one reliably at all, because it's not really scoring with these scoring actions. You can also see how it tries to use this get direction to basically translate these strings here into proper directional vectors. And that's basically where we go towards the how can we do better if we would write this on our own. Let's finally go about fixing that mess. So first of all, we've seen that this input parsing for the enemy units was completely omitted now. Let's re-add that. Make sure we parse these enemy units. Now if we run it, we can actually see this is working. It's actually doing something. It's not crashing entirely based on these bad input parsings. But we noticed that it's not yet working really well. So the comparison, of course, is really wrong. We want this to go and pick the winning position that actually scores instead of height 2. So let's change this to 3 and see. But oh, on this step, see, it fails to score. Still, something is odd. When you do some debugging, you eventually find out, oh, there is something odd going on with the directions here. Because if you look at this, and the coordinate system is left to right, is the x-coordinate increasing, and top to bottom the y-coordinate is increasing, which means north is actually correctly going up, but north east is in a different direction. And actually, is it up or is it left? Like the xy coordinates for the position are x and then y, and they are added to this directional vector, which means that this -1 goes on the x-axis, which is completely wrong here. With north, you don't want to move left, you want to move up. This one as well. And east is a similar thing, it moves to the right, so it actually increases your x by 1. East completely doesn't move on the direction of this other one. Southeast, similar thing, that moves to the right and down. This one is correct. But then south is again flipped, so it's 0, 1. Southwest, again, all the south should be 1. In the west, and the west is actually going to the left, so it should be negative for all the west coordinates. Nothing if you go purely west on the y-axis, and if you want to go north, oh sorry, this was correct, the -1. Now, we fixed basically the directional vector when it's added to the position, and that basically fixes the new position. So when we debug it and try this again, it's kind of the same step, still failing. So we need some more debugging and find out what's going on, and eventually find out that similar flip happened on the part here, because if you look at the grid, it's actually organized by lines, so by the y-axis, which means that that and that need actually to be reversed. So you want to first get the y-index and then the x-index for this kind of grid. And finally, once you do that, the bot is actually starting to do scoring and score something, which is still not enough to beat the tutorial, but just basically getting us started. And as we've seen, the AI has already messed up a lot. So this was a little bit of a different video where we looked at AI in the competitive programming area. While the AI is really strong in solving small localized puzzles, these more general bot programming things, it kind of struggles with that, as you've seen. And that is, in at least to what I understand of it, in terms of what LLMs do with the most probable next piece of code, it messes up the logic. Like you've seen these grid systems with x and y coordinates being interpreted differently on different places in the code. Lots of these small things sum up then, and in the end, it's basically not able to come up with the complete program. Well, yeah, we'll still hope that this gets better, of course, but I've seen at the moment, it's just not there yet. It's still a good help. You can use it initially to get started, but you have to be very careful, and we've seen a lot of these small pitfalls that you can fall into if you're not aware of what it's doing and changing. I hope you enjoyed the video. Let me know in the comments below what you think of it and if you want to have more content like this. Thank you very much for watching this, and have fun developing.